Yeah, I know the situation.
So I need 2 hours sleep. Then I wasn't business. I was upgraded to business class, so I did get some sleep. So it took 37 hours door to door just to get something.
Let's go ahead and get started.
I just noticed an error on the slide.
It's not July 15th, 2016.
That's what I get for using the
Or time travel.
Yeah.
Okay, so welcome to the Modern Working Group at the July 15th, 2016 version of Singapore.
Better known as the November 15th.
Quick note well of the note well. You've all seen the note well, so I won't note well too many more times, but it is important. Please pay attention accordingly. We have a note taker. Is anybody in the Jabber room that can relay for us? We do have 4 people. You won't be attending there, is it?
Use the microphone.
And I'll try to use the microphone too. Thank you. Can anybody relay for us from the Jabber room? I suspect we will be getting some comments. So, is anybody there that can do that? Please. I can't type. You're looking at my screen. No. No Jabberites?
People can use the Meet Echo thing, right?
Yeah, I guess anybody who needs to make a comment, please do it through the Meet Echo. I guess if we can't get somebody from the Jabber room. Okay, so agenda. We have just an hour here. A couple of very interesting topics, I think, that we'll go through. I understand that some offline work has been going on here that should be interesting to see. Any comments on the agenda or agenda bashing that needs to be done? If not, then first up is Chris.
I can go first. Why don't I go first?
Okay, first up is John on the Modern Terry draft.
I think I talk about you. So. Is this thing actually working? The monitor here? Maybe I will rubberneck my way through this. That's probably simplest. So yeah, we're going to talk today a little bit about Terry. Terry, for those of you who have not attended modern meetings in the past, and I think I see faces that look kind of familiar to me looking around this room. Terry is a candidate protocol for adoption here at Modern to try to, can you go to the next slide? To try to really figure out a way to normalize 3 functions that we use in the administration of numbers. Chris Witt and I actually spent some time since we got here in Singapore hanging out and talking about this. And I know this has helped clarify for me a bit the distinction between these 3 interfaces and good ways to describe them. But it's there pretty much to allow 3 kinds of operations to happen. One of them is allocation operations. An allocation operation is a request in number administration where some entity wants to get a number assigned, probably, or a number block allocated, but they can't do it themselves. They lack the authority to do it themselves. They kind of have to ask somebody else. So an example of this would be, an end user who's going into an AT&T store that's going to be using some interface. That interface could acquire a number from AT&T from a block, and AT&T would end up creating a new Terry record that they would sign for that particular new number that's been allocated and assigned in this case. All these operations end up operating on Terry records. That's kind of the core concept behind Terry. The second of these operations is the management operation. And this is an operation that's basically about pushing a record. There are Terry services that exist. And if what you want to do is to take a record you have and put it into a service, you use management. That could be updating or modifying an existing record in that service as well, or it could be provisioning something fresh that hadn't been in that Terry service before. And finally, there's retrieval. Retrieval is a search-like operation where you want to get a Terry record. A Terry service exists that has records in it. You say, okay, within these given search criteria, give me one or more records you've got that I should see for that if in fact I'm authorized to receive them. That's the basic idea. We think that most of the things you could conceivably want to do with numbers come down to those three basic operations. And that's kind of the core idea behind Terry, to have a way that we can define records that is kind of equally valid for all three of those use cases. And this is what's so different. We have Bernie in the back here, and Bernie's only here because he used to chair this working group we had here that was looking at ways to do provisioning for then enum-like systems, right? And one of the things that I think in retrospect we got kind of frustrated about when we looked at how enum worked and what it'd be like to provision is the kinds of objects we ended up creating to provision into enum servers weren't anything like what the records were actually in the servers. And the kinds of questions we wanted to ask about them, we asked them with a protocol that had completely different semantics, right, than either the records or the things you use to provision them. And if there's any one thing I think that, we kind of, when we blue skied this, the realization we came to is we need to look at this like there's an ecosystem, like a life cycle for these records. And that the same records are the things you create, right, and get signed, the same things you provision, the same things that you retrieve. And so if you're here to see how we're destroying your life's work here, Bernie, that is the respect in which, again, I think we're doing something slightly different than what we were doing back in the day. I'm just teasing you. Yes, I'm just teasing. But I think it does explain kind of what the motivation was for revisiting things this way. Next slide. And, so we have a picture. There are these clients, there are these services. Basically, there's a concept that there are people who are authorities. Authorities tend to have credentials. We think of them now pretty much like their STIR credentials, like they're the credentials we talk about in STIR and in ACME these days. And the authorities use these credentials to sign records. And they provision these records up to the service through something like the management interface I just described. And then all kinds of clients can use the retrieval interface to access these services and get the records back. And ideally, these clients should be able to see these signatures that the original authorities generated when they created these records and use those to decide whether or not they trust them. And this is kind of another thing that I think is very different about this model than the way we thought about enum or kind of anything that was down to like, should we have this like big flat file database in the sky, is that that fundamental concept that there are authorities and that the authorities are going to have some cryptographic assurance that is going to propagate through the system, and that the reasons why you trust a record or use a record, if you're one of these relying parties, is because you trusted that authority. You might not trust the service at all, right? To which you might have any trust relationship with it or any reason to trust it. It doesn't matter. The trust that you have comes from the authorities that generated the records rather than from the service itself. That is not to say the service might not do various kinds of policyist functions, but that's the fundamental idea here. Next slide. So the way we've defined these operations, they consist of a request and a response. Requests and responses have concepts like there's a source, a subject, there are restrictions. If you're doing a retrieval request, like give me all the numbers in this area code or something like that as an example of this kind of restriction you might ask for. We have a concept of response codes, but this is all defined in the base Terry specification in a way that's very abstract. We have an idea there would be a binding, a way to take a given protocol and kind of show how the semantics of a request and a response map onto that protocol's primitives. So for HTTP, which is likely to be the binding we're going to use for most of the things that we're interested in here, it has its own response codes. It has its own ways to define requests and responses. You encode the subject into this RESTful aspect of the URL that you're actually referring to and things like that. It is our job, once we all agree that this is interesting enough for us to do it, to then go take that next step and say, okay, here's how you map the semantics we've described here onto something concrete like HTTP. But this, again, going back to the many failings of enum, and I have as much responsibility for them as anyone does. You know, we didn't really think about things that way. We really thought about, let's take this protocol and it has these capabilities. Let's figure out how to like cram as much stuff as we can into it and like limit, overload anything we need to. So in order to avoid that, we've focused this effort initially on just let's figure out what the semantics should be, and then we can figure out how to map them onto protocols to do the job. All right, that's pretty much as much of a refresh of what Terry is as we're going to do. I guess I have one more refresh on Terry's slide. I've already talked about how they're collected services. It's important to say when we talk about a service, don't imagine this like there is one service in the sky, right? I know I showed a picture where there's a service and all these authorities are pushing records into it. Services could be radically distributed. And this is something Chris is going to be talking about right after I'm done, which is ways that we're looking at doing peer-to-peer and distributed services of various kinds. Be aware as well that we're not considering records as something that are monolithic or unique. There could be in a service multiple records that cover a single TN. There could be a record in a service that covers a block of numbers, one that covers just a single number. And when you query with the retrieval interface to find records for that number, you might end up getting back both of those records if the server's policy thinks that you should. And you'll trust those records based on how well you trust the authorities that generated them. It's a very open and flexible model that way. And yeah, we have a whole ontology in the modern framework that lets you know how we think this maps onto government entities, onto communication service providers, onto registries, registrars. But really, we see this as, again, something that is applicable to a very wide range of scenarios, some of which look very much like number administration today, some of which look like things we think are plausibly ways we might want to take this in the future. And that indeed was the exercise that, in part, Heading inspired by having FCC workshops asking us kind of blue sky about ways to do this. And we've tried to think about you know, what seems most flexible for what are the likely future compatibility scenarios. Next slide. All right, so a lot of people heard me talk about this for a long time, and you know, we're to varying degrees either bored by it or saying, oh my God, you're trying to figure out a way to make it so like end users own telephone numbers and carriers own nothing. This must be stopped at any cost. And rather than kind of perpetuate that fixation on those particular use cases, we tried to find a use case that seems like something people wanted today. And the simplest one for us to come up with that happened to be going around in North American circles at the time was this concept of figuring out how to share which telephone numbers are valid and allocated at any given moment. And this is a use case that's kind of related to the STIR work in that it's very useful to know, especially when people can kind of impersonate arbitrary numbers, what numbers are valid, what numbers are invalid in a numbering plan, and what numbers happen at any given moment to be allocated or assigned. And so we decided to say, okay, a good way to kick the tires on the overall data model and system that we've been very abstractly constructing here, let's then take a very concrete example and show how we could apply that to this. And so we produced an internet draft about this. And again, our hope is that this could be used to share information between carriers to help them decide what kinds of calls perhaps they should give special treatment to or even block, depending on the regulatory environments they exist in, if they are invalid or unallocated. Next slide. So the approach we have in Terry Valid basically takes the fundamental record concept, and I'll show you a record in Terry in a moment, and adds a new element to it. And this element is called allocated. And we have 3 values for it in the way that we've defined it. The most important thing to understand, I guess, about invalid numbers to start is what it says at the bottom. The idea behind these records is to treat them as a kind of whitelist. If there is a record that an authority has signed for a number range in North America, then it is a valid number range. If you interrogate the set of signed records for a particular numbering plan and the number is not falling within a valid record, it is an invalid number. So in other words, this assumes that we would build an allocation map that is exhaustive for the blocks that have been assigned for this particular numbering plan. The reason why we chose that approach is we thought it was easier to describe the numbers that existed than all of the possible ways you could construct numbers that are in fact invalid, which seemed like a kind of complicated problem actually in a number of respects. But the basic idea was, yes, to break this into these three categories, where you can either say for a given record that would show a number block, and we have kind of two flavors of records I'm talking about. You'll see me use this R and T. So think about R records as representing number ranges, prefixes, blocks, like a 10,000 block, a 1,000 block. T records tend to be for individual numbers. So we want to be able to say either yes, this is a number range that has been allocated. That's not saying anything about whether individual numbers within it have been assigned or to who, merely that it has been allocated. This is the kind of thing that a high-level registry, like the North American Numbering Plan, for example, could generate as a record and say, we as the authority know this particular NPA NXX, or as a pooling authority, this particular 1,000 block has been allocated. Assigned means something much more narrow. Assigned means for this particular number, so someone is at least using it, or is at least capable of using it. It's not merely allocated, but there is some entity, some customer, perhaps a carrier, to which it has been assigned. And no means this is a valid block, but that no numbers are currently assigned to it. There are NPAs, for example, that we know are valid NPAs in the North American Numbering Plan, but are not yet in use. And so this would be for things like that. Yes, Henning?
This may well be out of scope, but I'm curious. It seems to fit roughly into the notion as describing the high-level nature, so to say, of a number. So there is another set of kind of numbers, namely, which exist but should not be used. For example, the 555 numbers. An example of numbers that are, they are allocated in some sense. in a sense that they have a known status. The known status is they don't really exist. They are reserved for whatever purposes. So I wonder, and
that would be no, I think.
Yeah, and so we just need to be, my sense would be that being more explicit as to what that means, because the notion allocated is kind of, as you know, is kind of a little on the vague side. So having a little bit more of what is the property of a number, and then you can indeed say these are allocated. Because what you mean by allocated is you shouldn't be surprised if you receive a call from that number.
Yes.
That's kind of the implication from a practical perspective. It's not just some, and having more information as to what that is. So, for example, test numbers would be one example of that. That in some circumstances, you want to know that, yes, this is indeed a number. And if you see it internally, it's probably, it may be a good thing. If you see it externally, obviously it's a bogus number because nobody has ever been given those test numbers. So I would want to think about as to, are there a more descriptive way, rather than having yet another kind of query, that you can have if you map them broadly as in, yes, I should be able to receive calls from that number, no, I shouldn't, and then here's some additional information as to what that number happens to be.
Mm-hmm.
That's fine, but that might be fit into that without creating anything. The other one, since if you're going to cover that, tell me. The other issue, as you know, that's garnered a fair amount of regulatory attention is the reassigned numbers. And haven't thought this through, but it seems like you could relatively easily extend that, not for number ranges. That would only obviously apply to individual numbers, namely, when was this number?
When assigned, you could do recently reassigned. It's like
when was it reassigned? Because the algorithm that you would want to use, what people want to be able to do is they say, I have gotten permission from that person to call that number, whatever, in July. Mm-hmm. And the number was reassigned in October to somebody, which means somebody else now has it, which probably means I no longer have permission to call that number because it has probably been reassigned to somebody else. Yep. So that is again, that doesn't reveal anything of any significant privacy concern, but it tells me immediately that whatever permission I had as a bank, for example, to call that number is no longer relevant. So again, you might want to, instead of having 10 different queries, we might want to think about as to whether they all fall roughly into this type of public information necessary to determine whether a number should be called, should be an originator of a call, or could be an originator of a call, and what else do I need to know about it?
Yeah, so I mean, certainly I'd say in the design of this, we came up with 3 values. It could be that there are more values that are useful. For the 2 things you just described, I would say I can't imagine for assigned in particular, having an assigned date be something that is available as like an optional field attached to that, right? So yes, it's allocated, it's assigned, and it was assigned on the following date. Seems like a useful thing to be able to add to that. So I'd be happy to put that in. The no thing, it's interesting. I mean, you know, when we talk about like an area code not in use yet, if you actually read the draft, I go through actually in some detail things like easily recognizable codes. I go through, you know, all the cases where you'd want to use no because these things have, or what's been reserved. Like we have whole sections of, you know, NPAs that are reserved now, right, too. That general blob is what I wanted to flag with that. So I'd like to think that's sufficient for that kind of thing, like ERCs or reserve blocks. The test thing is more interesting though. Like if this is a test number, that's something more I might want a 4th category that actually says, yes, this is a special thing and you should treat it specially because of that. But I hope for things like ERCs or for unassigned blocks or even blocks that were assigned and then reclaimed, which there are a couple of those, right? That should just fall under no. And there's really no other reason for no to exist. Otherwise, we just not have a record at all, right? Like the reason why that we distinguish between no and having no record is because these things, it's possible in the future they could be used. That's really what I think no as a group case means. Yes, Chris.
I think the historical thing is an interesting thing. I've been sort of vaguely thinking about it and whether or not it should be explicitly part of the record or is it just a database thing that's queryable through some separate thing. But knowing all the historical, you know, porting or whatever and all the signatures associated with that and, you know, any potential activity that, you know, like we talked about error conditions or service provider 2 tries to allocate a number in service provider 1 or, you know, some of those types of things, like, do we maintain that or is that separate or?
I mean, I could definitely imagine having a whole historical kind of extension for these records in general that would point you to either an index to prior records that this is tied to, right, and the date in which, you know, this record was changed in this way. I mean, so we obviously this whole model is designed to be extremely extensible in those kinds of ways. These are just JSON objects, right? So
right.
Effectively. So I mean, yeah, it's exactly getting into the weeds of what those are that we need to do, right, to turn this into something real and not just theoretical.
Right. I was trying to say
like
beyond just reassignment, you know, there's probably other use cases for historical.
Yeah.
Again,
Sorry. I think the important, because you know, it's extensible and all of that, is that if you want to add more information kind of as additional background that you may not care about in some cases, but that may give you better diagnostics, that like you got a test number somewhere that showed up in a place that it wasn't supposed to, that tells you something interesting.
Mm-hmm.
I don't know what it is, but and so having a more finer granularity there. But in terms of use case, what we seem to be, this seems to be information that is, unlike some of the other stuff, that is likely to be at least semi-public, as in most of the stuff here is known currently. It's in spreadsheets, whatever, LIDB type databases, whatever it happens to be. So well, you might have to pay for it, but it's certainly not a national security.
We don't have a lot of this. I'd love to have more of that category.
Right. Yeah. But it's, the idea would be that this is not stuff that reveals how many customers your carrier has, all the stuff that carriers worry about in terms of privacy. It's simply, unless the carrier itself publishes it. Yeah. But if the database administrator or regulatory agency were to publish it, it simply says somebody in my universe has this number, meaning if you receive a call from it in itself, it's at least it passes that check. Mm-hmm. And so maybe focusing on what is the kind of use case, kind of a level, and so that we don't stuff stuff in there that is likely to be seen as confidential or proprietary, which this seems to do, but I want to have all the information that I can put there as opposed to having 17 different Terry
Let me go to
records.
the next slide because this will help with this, I think. Next. So yeah, first of all, this is just what it looks like, right? Here's a valid block, allocated equals yes. So this is just to show fundamentally what kinds of things. That ... is for all the rest of the junk. There are signatures and so on that go into every record. But go to the next one. Yeah, I mean, the idea that we have these in two record categories, there we go. You know, so basically there is a distinction between this individual assignment stuff and TN ranges. I think the TN ranges are more in that public, you know, space of this. The allocation for individual TNs, there are going to be some cases where that's going to be public information. There's going to be other cases though where I'm not sure carriers are providing anyone, unless you really pay for it, as you said, real-time information about which numbers are assigned and which aren't. So I think it's much more likely that kind of what we proposed in the draft because of this is to kind of just, again, because Terry has this ability to say, okay, a service can have records in it, some of which are for ranges, some of which are for individual TNs. What you get is what you get depending on what the service is willing to give you, what you were authorized to receive from it. So I'm just saying, let's just treat those as completely different categories, right? And if you're authorized to get all that information, both the R and the T information for this, then you get it. And if you're not, you don't, right? So I think the data model has it right to make it work that way. I haven't made them hierarchical, just separate. You know, I do want to make sure people get that, you know, like there are people who feel strongly we should make this hierarchical. I've heard that argument. But well, we want to make sure that within each range, you know, the T records are all embedded in the R records under the, you know, and I think having it be a mess is better for exactly this reason. Just having it be like a bucket of records, some for ranges, from individual TNs, and you get what you get depending on, you know, who you query and what they're willing to give you.
Isn't it naturally hierarchical just from the fact that it's a number range that has numbers underneath it?
I mean, it's naturally hierarchical in that sense, but
I don't think we need to think about the database per se and how that works.
well, you do in the
Do
sense
we?
of we're defining records, and the records we're defining have a certain atomicity to them. These aren't just like, you know, SQL fields, right? And because different people sign them, so the records have this like cryptographic wrapper around them, and some specific authority generates them. So because of that, I tend to not actually think about them like they're hierarchical. I mean, this is a very important design decision, though. So we need to get clear about it. I mean, I think that there could be different consumers for that R information than there is for the T information. There could be different people who are authorized to have it, and so because of that, I'm disinclined to link them that strongly.
I mean, what you can have happen is, if I understand correctly, particularly if you want to make the descriptive part a little bit more flexible, is that you have a fairly blanket description of a range, namely the area code is in principle allocated to somebody.
Yeah.
But because we know that allocation, because even in today's system, it kind of percolates down, so to say, all the way to until it reaches kind of the carrier level. John Doe has a number, and the number before and after happens to be not yet assigned, but they got the whole block assigned to the carrier at that point.
But in portability is another wrinkle.
Portability is another one, but leaving that aside for a moment. So the notion would be that a single number could have a very high-level description as part of a range, and a more detailed, for some subset, could have a detailed description. My other concern, again, just because, like you said, we have a number of different publishers of this information, could be a regulatory entity, could be a general number management entity, et cetera, done to a carrier or some third parties, is I would actually argue that having an explicit way for somebody to say that I believe that these numbers are, like I said, invalid, as in you should not receive numbers from that, is actually a good thing. That you should expand. If I have on good authority,
Like unassigned.
Not just in your kind of, it can be assigned, but they're known to not be assigned, and then we can do that. I don't want to, we're running out of time.
So
Yeah, we're running out of time, so
Okay.
we can
Yeah, that's interesting, actually. So we could do this as to have both assigned and unassigned be things you stipulate about an individual number, for example. So like a carrier could say, I'm going to generate a record that says this individual number is unassigned. I know because it's my number. Yeah.
Brian Rosen, do you really want to make it this North American specific and in particular not have prefixes?
Oh, so there are prefixes. There are things prefixes.
Well, but they aren't. They're ranges. So they have start, end, not
No.
prefix.
No. So that's, oh, sorry. So we have a prefix definition and a range count definition in modern, not in STIR, but in modern we do.
Oh, okay. Okay. You probably want to make that more explicit.
Yeah. So so modern does this differently, and trust me, it's causing us all kinds of problems. So we're fixing that. Next slide. Interestingly as well, we talk a bit about queries and propagation in this. This is stuff where I think I need to beef it up more in the document. This just comes down to the way that you use the management interface to make sure that you propagate out this information between Terry services. Some of this is relevant in particular to distributed registries that Chris is going to talk about momentarily. But I guess the important thing to say about that is it's easy to kind of read the way the draft is written now, like we're talking about taking an RTT, taking a network dip, like every time a call comes in to look and check to see if this number is valid or not. That's not actually what it means. Logically, we talk about that operation, but we imagine that actually there are going to be local databases of these records that are being collected, probably through the management interface, that will, you can imagine a regulatory authority, a national authority, bulk publishing out these records so that they're locally provisioned in databases where they're needed for people to manage this in real time. Next slide. So what do we need? We need energy and discussion. We actually had some discussion today. Discussion's good. I think there's some takeaways on this. Like I want to get into more kind of the unassigned dimension of this that is useful. Yeah. So, and there's some things about the terminology and getting that better aligned that we still need to do. But, again, provided people think like this seems practical enough that we might want to actually build it. Like, is this is always kind of my ask when I get up here and talk about Terry, right? Is this a concrete enough thing we're talking about that it's worth building the HTTP binding for it and saying, here's a system that would actually do this? And I think we're pretty close on this now, actually. I think this is something that it might actually even be useful to people today to like have something that does this, which is perhaps not been true of some of the things we've discussed in the past. So if people, having seen this as the most concrete use case we can come up with, think that it's time to start talking about how to build the RESTful interface that would actually do this, I'd like to talk about that. Pretty.
Björn Hyneisen, yeah, as you said, you're destroying my former work, and it's fine. I just wonder, one part of my former work was validation, who is entitled to actually publish records? Could be a service provider, could be an individual. How is this fitting to this framework? Can you elaborate it a bit? Or?
The architecture slide, the one picture that's back here. Yeah. So the short answer is we assume STIR. In the sense of, so these authorities here that are capable of generating the records to get published, they have to have credentials that they sign the records with. Records have signatures built into them. Mm-hmm. So we assume that they have credentials that actually have a scope of authority for number ranges in them, because STIR can assume that.
Okay.
That's the answer. Yeah, so, any feedback on that? Like, should we do this? Is this worth pushing this forward? And trying to make a...
Yes.
Henning says yes. So Henning says we should actually do the work of getting the protocol interface for this. Because we just, I don't want to do that unless people think this is useful enough and that there's something with enough meat on it that's worth doing. And
There are two reasons. A, I think it can actually be basically at least two use cases that we already identified, both in restore-ish type of environment. And the second one is it is sufficiently simple and sufficiently read-only that it offers kind of a first good test case to see if this whole thing works. And works as in it's not too complicated to do, and does the international stuff and all of that. And having something, and it's sufficiently simple that this is something that a hackathon could do.
Yeah.
And
Chris and I were talking about that.
So before we get into more complicated, more state machine-based allocations and all the stuff that mimics classical number allocation and portability issues, this seems like the simplest test case to do. So yeah.
It was done precisely for that reason, yes. Okay, thanks.
Chris, you have about 10 minutes.
10 minutes, okay. So this, as John mentioned, was sort of the result of some of our conversations and then trying to map things to DRIP and also validate, I think, our understanding of how these things would work and make sure we're aligned. So next slide. It's just the overview. Actually, we can go to the next slide. So I made this picture. Hopefully this makes sense to people. Trying to map the roles that we defined, registrant, registrar, the idea of an administrator, and the services that would have to be available in maybe a real deployment of this, and then also the DRIP part where records are being passed back and forth as part of the distributed registry. You have the local records at each thing. You have the Terry server. You have the database, the local database where the records are stored, and then the DRIP node, which basically has the interface for when you want to update a record, you pass it out, it goes through the voting phase, and then commit, and then you write it to your local database, and it gets written to all the other local databases. Any questions on that? Good. Next page. So one thing I was trying to wrap my head around was request response and some of the interaction models, and we had some conversations about this. So this is sort of a prelude to the next slides. Basically, request response is good when I want to request some data and get some back, but I think there's some assignment operations and other things that may require a little more than that. So next slide. So I'm sort of making the assumption, and I think we're in agreement on this, that all these transactions are registry-based. And what that means is if I think the major example here is the creation of a number block or the request for a number block. If you're not the administrator doing that, if you're a service provider doing that, you need to have some sort of pending status or request status for that number block, and then an authority would have to come back and then do another registry transaction that would maybe sign over top of that record to make it official, or some sort of process like that.
Yeah, I mean, so John, here again, the one qualification of that is, of course, again, so creating any Terry record requires you to have this credential, right? And so it really comes down to the fact that if you give 10 people a credential with the same scope of authority, this is what creates this very interesting problem for doing this as a distributed registry. So you imagine that there's a block of 10,000 numbers, and you give 10 carriers the ability to authority over that block. They can create records for numbers in that block. That's when you get into these potential areas of conflict, right? Where they can create this record and push it out, but then there has to be some central way that you ascertain who did that, and that becomes authoritatively enshrined.
Right.
If you have a model where instead of those 10 carriers for that 10,000 block, each one gets 1,000 numbers, right? A credential for those 1,000 numbers. That's one way to do this where those conflicts can arise. There are also ways to do this where you have to go and kind of pull the registry first to get the credential that's necessary to create the records that you want to create. So there's a bunch of different ways to skin the cat, and exactly which is the right one, I think, is where we're still like. Yeah,
I think that's based on policy, and we probably want something that's independent of policy, but there will be a hierarchy, I think, of levels. The simple model is a service provider, has an OCN that represents their ability to request numbers and all those things, but they don't have the ultimate say to like, okay, I'm going to allocate this block and just take it away, and I'm going to allocate every number in the universe or something like that. So there has to be some two-way transaction there. You can go to the next slide. So yeah, that sort of leads into what I was just saying. I think I started calling it 1 step and 2 steps, and maybe there's n steps, but this idea that there's different transactions, and so we can go to the next slide.
Yeah, and just to jump in on that, I mean, the way that's exactly what the allocation interface does, right? The allocation interface is exactly for that case where, you can't just do it unilaterally. You have to go ask this authority first, can I do this? And it gives you the credential or the record itself from that.
Exactly. Right. And I think I'm trying to just classify at a higher level, what types of interaction models are there going to be, and can they be supported by the model where you're doing things record-based, and it has to work over some distributed thing as well. So yeah, I talked about a two-way was more of an allocate. Assign, maybe you have the credentials to allocate within that 1,000 block or 10,000 blocks. So maybe that's just one transaction because you can just sign it and assign it. And then I also was thinking about error conditions, how do we handle those? I have some other thoughts in the next slides, but what does happen when somebody tries to allocate something in a one-way transaction and then it's a false, and we have to consider those cases. Do people just not trust it because it has the wrong signatures, or is there some cleanup that has to happen? If that happens.
The messy Terry story of that is that so either a server could have a policy that if it looks at the record and sees that the signature doesn't have authority for the number range it's discussing, it would never keep it, right?
Right.
But even if it does keep it and it passes it to a relying party, the relying party can make the same check, right?
Correct.
So it can kind of happen in either of those steps, and it's a matter, I guess, of server policy how it chooses to do that.
Right. Next slide. Yeah, so I sort of went through each of the 3 classes of things: acquisition, or are you calling it allocation?
Whatever.
Acquisition.
Terminology is still TBD.
I guess in my sort of HTTP CRUD style thought process, I was trying to map these things, and I think for the most part it works as far as I can tell, but acquisition mostly corresponds with create operations or put in HTTP. Next slide. And then management is mostly about modifying records, existing records, or adding information to them. So, and correct me if I'm wrong on this, in your mind, this corresponds with mostly update or post operations. And then next slide. And then retrieval obviously is just get retrieving information. So hopefully that helps and makes sense. It does for my mind. Next. So I had a couple thoughts here about the drip dependency. In drip, if you recall, there's a voting phase and a commit phase. If we wanted to take advantage of the fact that drip is a 2-stage operation, we could do some validation on the voting phase. Right now, drip does say that you pass the payload in the vote. So somebody could, like authority, could vote no, just intentionally because you're doing something that you're not supposed to be able to do, rather than, so just some thoughts that we could actually take advantage of the process itself, but that would be specific to a distributed registry. It wouldn't obviously work on a traditional one. And then next slide. Yep, Henning has a comment.
In a non-distributed registry, presumably there's, because everybody knows that there's one authority, and we assume, I think the assumption was, and you didn't state that, but it's clear, is that the registrars are well behaved. They're not malicious.
Right.
and we assume that they might be faulty but not malicious.
Right.
And so that if the registry says yes in a centralized model,
Yeah, I guess in a centralized
then
model,
it's good.
right.
And just like today, I think that this is if you get the confirmation from your registrar that you got your domain name,
Yeah.
generally speaking, if that didn't happen, unless some error happened,
Right.
then the registrar needs to, you have a referral to ICANN pending because your registrar went rogue.
Right.
And I don't think we want to deal with that case
Yep.
here in the centralized case. In
Yep.
the distributed case, you always have you do have to deal with it, namely you have various race conditions,
Right.
and you have various conditions where disconnects happen. So two parts of the distributed systems got out of sync and they get back together, and then somebody says, nah, didn't work.
Right. I think with distributed, we want to assume that all actors are somewhat honest in doing the right thing unless a mistake was made. We have trust but verify in terms of the signatures, right? But the nice characteristic, I think, of distributed is I can do things locally on my version of the registry. It gets propagated and validated, and then,
Right.
and then everybody has the information real time, and, but I
So
think
that's why I would like
that's sort
to
of
vote
explicit.
to have that characteristics, because that gives you the real-time thing
Yeah.
without doing much of anything. So.
Right. But we have to, I'm just sort of stating that explicitly because that is one of the advantages of doing that. And yeah. The other one, and this is just a thought, it's may or may not be, may not matter. It might be just an implementation detail, but since distributed registries are more on the order of seconds rather than milliseconds, do we have to think about anything in terms of asynchronous operations, or do we, if we come up with some HTTP interface, do we want to explicitly make it asynchronous versus synchronous, meaning your HTTP request is one transaction and then you have some push mechanism that gives you the response when it's fully propagated throughout the network. So just another consideration for once if we start doing the APIs for these things. And I think that's it.
So who am I asking this question? Either you or Adam. All right. So post, put, and get. So if we're in allocation, we're saying there's a record that doesn't exist yet, and I want you, the server I'm talking to make a new location with this thing in it. Is that post?
That's usually put.
That's usually put.
So,
So it's probably a location that doesn't exist at all previously.
right. The distinction that you usually make there, and I'm not the expert here,
Microphone.
but I recall basically,
Yeah,
Okay, Adam, you can.
Microphone.
sorry.
Thanks. No, the distinction that I usually hear on this is that if you have like if get of X, if put of X followed by get of X returns the same value, then it's a put. Otherwise, it's a post. As being your key distinction. But this is a sort of thing where I would generally impose on someone like Mark Nottingham to set the record completely straight.
Yeah, I mean, there is some different philosophies, but in general that I'm aware, put is, there's a new record. Post is like an operation that's general purpose. Like I want to do XYZ things to the data. It's used in lots of different different scenarios, whether it's just modifying a record or actually want to like start some action working or whatever. Because post, you put the payload in the request, and you generally get a response with a payload back confirming that. But anyway,
I'm
I
going to
mean,
suggest
again, the interesting thing about the put, I know we don't have much time.
we
table this.
we can get other opinions on
Yes.
if necessary.
But I think this is very promising in terms of this, again, is making concrete how we even put all these pieces together, right? So I think we're getting somewhere.
Yeah, I suspect I was actually going to try to create a document. I didn't, but for this mapping, I'm assuming going forward, we would probably want something like that specifically, apart from the drip spec itself. So that would be the plan going forward.
Thanks, Chris.
So I wanted to give, and I can be very brief with this, quite frankly, an update on nationwide number portability. So if we go to the next slide. In 2016, seems to be a theme here, there was we put a draft use case in. It's related to something called nationwide number portability. This is something that was going on in the US. The FCC was looking to do this. Why don't you move on to the next slide? Bunch of work done in 2016. Things kind of went dormant for a while, but there's some recent activity. It's back. So the FCC put out a notice of proposed rulemaking and a notice of inquiry related to the work that was done on nationwide number portability. So to put the two things together, there was a draft that was a use case because the one proposed solution for nationwide number portability had a brand new numbering resource, basically in the US, a new area code that would be used as a routing number and would help facilitate deployment of nationwide number portability. They've brought this back up. They've asked specific questions about the solution that was actually covered in that draft, because that made its way to an ATIS document. And some of the things they ask, if you see in paragraph 37, we want to know how number administration might be improved, realize more efficient technical, operational, administrative processes. In paragraph 54, if you look towards the end, they say, we understand there can be new things done, such as combining the processes of number allocation and porting, or allowing distributed registries where it used to be done authoritative registries. The point being, these are things that we're discussing here, is really the main point that I wanted to point out, that there does seem to be some recent activity that is relevant to stuff we're talking about here. If you go to the next slide. So I won't go, due to time, I won't go too deep into the solution. But again, the solution calls for a new numbering resource, a new area code. This would be used for a non-geographic area code, be used for routing numbers. It also calls for a parallel IP PSTN, creating a new PSTN. So you have kind of the old TDM PSTN and a parallel IP PSTN, and this is where the non-geographic numbers live. This is where they're routed. So because the numbers are on this IP PSTN, gives the opportunity to do things differently than we do today. Gives the opportunity to conserve numbers, no block assignments, more relevant telephone-related information model, Terry. New bindings and encodings for how you access, you acquire, retrieve, manage the numbers. Distributed registry model, they referenced it themselves in their order. Let's see, if you go to the next slide. So quickly, what the problem is ladders. The country is divided into, the US is divided into 204 ladders. These are little geographic areas, some of them big, that this was created in divestiture. Lex carried number calls within the ladder, but long distance had to carry calls outside the ladder. Bottom line is, the network's been designed like this. They've designed the switches like this. It's created a problem. You can't port a number out of one of these ladders into another ladder. That's sort of the problem. And, you know, I kind of call this, because of this legacy problem, it's sort of a Y2K problem. We don't even know where the problems are. If you were to try and break this, if you're trying to make move numbers from one geography to another with our current infrastructure. So if you go to the next slide, so The solution calls for a parallel IP PSTN with a bridge between the two, and the bridge is these non-geographic routing numbers. This is this new numbering resource that in essence lives on the IP PSTN. Calls to the non-geographic routing numbers on the TDM network are routed to the IP PSTN for call handling. The reason for the non-geographic routing number is any TDM switch can route an area code. There's, we can't do something where you have to make a change to the TDM network, but routing via an area code, any switch can do that. So if you go to the next slide, so here's kind of a high-level vision for what that IP PSTN would look like. You see connections to the PSTN, the TDM PSTN, connections from these things I call non-geographic gateways, which are, look at non-geographic gateways as the tandems in the TDM network. I didn't go into it before, but basically there are in essence 204 tandems around the country and 204 ladders, and in order to get numbers, you have to connect to those. This would be sort of the equivalent, but it wouldn't have any of these geographic problems that exist in the TDM PSTN. And to go to the next slide. So to summarize, let's see. On the TDM PSTN, there's kind of an existing process. The geographic number would be ported to the non-geographic routing number. On the IP PSTN, new processes. We have all kinds of new processes. Mapping the non-geographic routing number to the gateway. Non-geographic gateway would acquire, the providers would acquire the non-geographic routing numbers. The gateway providers would manage the routing numbers. They tell what the address is. Networks would have to retrieve this information. And one other thing I like to point out, service providers could use this process to migrate their customers and their telephone numbers from the old TDM PSTN to the new IP PSTN. I like to say cap the TDM PSTN and grow the IP PSTN. So in summary, in the last slide, so what does this mean? So it seems that the US FCC is still interested in future of numbering and number administration issues. Modern is still the only work group that has working on global standards for numbering in an IP environment, and we'll learn more in the future. Oh, one more thing I'd add, which I found out after putting the slide together. FCC has a advisory committee called the North American Numbering Council. They've recreated it just yesterday or the day before, and they've added a nationwide number portability work group to that work. So yes, in fact, me and Henning happen to be on it. So again, bottom line, seems to be interest in the stuff that we're doing here. Any questions? Okay, thank you.
You went faster than possible.
I'll ask you, since we have time, 2 minutes. Just to make sure I understand what's going on. For this thing here is, would you imagine that for every number that's assigned for portability reasons, you would get a unique number within the area code, or is it more like the existing number portability model where you get it per carrier as opposed to per TN?
It's like, yeah, you could look at it two ways. It could just identify the non-geographic gateway,
right,
period. Likely the non-geographic gateway providers would have multiple customers behind them that they're supporting. So I could see non-geographic routing numbers per carrier that they support.
So that's also,
but not per number, definitely
yeah,
not.
So this is somewhat similar to the existing model kind of thing, except that obviously it's a different
yes, and it's not
and
not block routed, right?
routed.
So today in
it's
US
individual number
portability,
routed as opposed to block routed.
That's right.
But it's not a remapping to because you could imagine a remapping to an individualized number, which would essentially then kind of change the portability model. Because
Right.
you're adding another layer of indirection at that point.
Right, right. And, I'd see that on the IP side of things, you'd have the non-geographic routing number, and then, likely something like a URI that would point to it. Maybe I know carriers love SPIDs, love routing on SPIDs. Maybe they have SPIDs.
Yeah, because otherwise, if you did have something more fine-grained, you'd obviously run out of numbers in an area code, because
Right.
you
That's right.
pretty much have, whatever, a few million of those
Yeah.
available now.
Yeah. And by the way, one of the other things I propose is that since we have this area code of 8 million numbers, why don't you just give out non-geographic numbers to consumers as well? So that they don't have to eat up geographic numbers in the states and in the area codes. I didn't mention that in here, but that's also a concept.
The non-geographic gateway, like NGGW and those acronyms, are they defined in a document, or you're just?
They are defined in the draft. Yeah, the draft's expired, of course. Yeah.
Oh, okay. In the one for this. Okay.
Yes. Yeah.
Sorry,
Yeah.
I didn't remember that.
Yes, yeah. And the concept is, by the way, that these people would be volunteers. Today, people are compelled, ILECs are compelled to provide tandem services. In this world, companies would volunteer and say, hey, I'll be a gateway provider. That sounds great to me.
Okay, we're out of time.
Oh, thank you, Steve.
Good progress. I think hopefully we'll get some energy, as John said, and have more specific things to talk about in London, and maybe some coding done as well. That'd be cool. Okay, thanks everybody.
Yeah, real quick. Did we want to try to do this thing tomorrow with?
Yes, Thursday.
Oh, yeah, sure.
Yeah.
Lunch, yes.
So what is there some plan for that?
Yeah, we need a place.
We just, oh, this is just a separate.
Yeah. I mean, if you got something in mind, great. Otherwise, I was going to get the guy who will start.
Anybody want to sign?
Yeah, no.
I was going to have.
I think I met him, but.
No. But I was going to say, hey, it was your idea, so why don't you do the place?